Hello dear students, how are you all? I hope you all are doing well. Before going in this video, please subscribe our channel Nirja Education. So today we are going to discuss how to represent a real number on the number line. In our previous section, we had a discussion about every real number has a decimal expansion. A real number can be either rational or irrational, and how to locate some of the irrational numbers on the number line like under root 2, under root 3, that we have seen in previous video. Now, how to represent a real number on the number line? Here I have taken one number 2.665. Is this a real number? Yes, this is a real rational number. Why? Because this number is having terminating decimal expansion. For that, I have taken one number line indicating all the positive integers on the right side, all the negative integers on the left side. As you know, number 2.665 lies between 2 and 3. So, take a closer look on the number line between 2 and 3. Here I have taken separate number line for 2 and 3 so that we can have a clear idea about it. Suppose I have divided this portion between 2 and 3 into 10 equal parts, and I have indicated 2 after 2.1, 2.2, 2.3 and so on up to 3. As again you have noticed, number 2.665 lies between 2.6 and 2.7. Again take a closer look between this portion, and to get more clear idea about it, I have taken 2.6 and 2.7 on the separate number line. As you can see, again I have divided this portion into 10 equal parts: 2.61, 2.62, 2.63, 2.69 and 2.7. Now again this number lies between 2.66 and 2.67 on the number line. Again take a closer look on this portion, and I have taken a separate number line for this so that we can understand more clearly. Starting with 2.66, 2.661, 2.662, 2.663 and so on, and here we got our number 2.665. So my dear students, this way you are able to locate any real number on the number line, and this process looks like we have seen this number lines through magnificent glass. So this process called process of successive magnification. If you have asked represent this real number on the number line through the process of successive magnification, then you need to follow this same process. First take a number line with that integers, take a closer look to the number, take the portion on which the numbers lies, elaborate that, again see through the magnification glass, again take that portion and elaborate that until you got your number which you have asked to represent on the number line. Now this we had a talk about how to represent a real number with terminating decimal expansion. Now how to locate the real number on the number line which is having non-terminating repeating decimal expansion, that I am going to tell you by next example. Now we are going to see how to represent a real number on the number line which is having non-terminating repeating decimal expansion. Let's see how to do this. Here I have taken one number which is 5.37 and repeating. Here only one number is repeating, 7, that we can come to know by this symbol. This is only on 7, so we can conclude that only 7 is repeating. And we have to show this up to 5 decimal places. So let's write this number first up to 5 decimal places, that we can write as 5.37777. 1, 2, 3, 4, 5. Now this number we need to locate on the number line. As you can see, this numbers lies between 5 and 6. So directly I have started with 5 and 6. If you want to draw a number line and if you want to indicate 5 and 6 first, that is also fine, you can do so. So here I have already taken 5 and 6. Suppose I am dividing this 5 and 6 into 10 equal parts, then I will get 5.1, 5.2 and so on, 5.9 and 6. Again if you see, this number 5.37 lies between 5.3 and 5.4, lies between here 5.3 and 5.1, 2, 3 here. Again I have taken this portion on a separate number line. Again I have divided into 10 equal parts by 5.3, 5.31, 5.32 up to so on 5.4. If you have seen, this numbers lies between 5.37 and 5.38. Where it is on the number line? Here 5.37 and 5.38. Again I have taken only this portion of the number line and drawn separate number line for that portion, 5.37, 5.371 so on up to 5.38. If you have seen, again this numbers lies between 5.377 and 5.378, this portion. Again I have taken this portion, again divided into 10 equal parts and also started with 5.3771, 5.3772 and here one 5.3777. This is up to only 4 decimal point, 5.3777, 1, 2, 3, 4. But in question we have asked to locate up to 5 decimal places. So we need to do one more number line. Again there is 5.3777 lies between 5.377 and 5.3778. Again I have taken only this portion and I have drawn a separate number line for this portion, 5.3777, 5.37771. Now you can see here we got decimal expansion up to 5, 1, 2, 3, 4, 5 and our number 5.377777 is here. So this is the place on number line where you can locate your number 5.37 and repeating up to 5 decimal places. This is very easy. So we have seen 2 examples of how to represent real number on the number line. In first example, we have seen that how to represent number on the number line which is having terminating decimal expansion. Same way, how to locate the number on the number line which is having non-terminating and repeating decimal expansion. Always if they are going to ask this kind of question, there will be given that up to which decimal places you have to do the decimal expansion and you have to locate the number accordingly. If they have asked 3, then you have to do only up to 3 decimal places. Here you can conclude your sum if they have asked to do decimal expansion up to 3 places. Here we have asked up to 5 places, so we have done like this. So my dear students, I hope now you are having clear idea about how to represent real number on the number line, which is very easy.